There's a problem with Earth's core. It's right here under our feet, but we've never actually seen it. Today, we're going to fix that. We're going to find a solution to drill all the way to the center of Earth. And then we'll see you fall right through the planet. This is going to be fun. Or not. Okay, let's open Earth up. Before going all the way to the core, you need to drill through the crust. Now, humans have attempted to drill through Earth's crust before, but as we went deeper and deeper, we had to shut that down and seal it off. And we didn't even get that deep. Yeah, this is the Kola Super Deep Borehole. It's deeper than the Mariana Trench. It's the deepest place on Earth. Scientists started drilling it in the 1970s, and over the course of 2 decades, they went through unexpectedly extreme temperatures, deep granite oozing like hot plastic, and snapping drill bits. And in 1989, the project was shut down. The Kola Super Deep Borehole is 12.3 kilometers deep. That's 7.6 miles. It's significant, but compared to the Earth's radius of 6,378 kilometers, it's barely scratching the surface. To get all the way to the core, you have to drill a lot deeper. Specifically, you'd need to drill 6,378 kilometers deep to reach the center of the planet, and then another 6,378 kilometers if you wanted to dig a hole through the entire Earth and get out the other side. But let's start with the crust. The crust is the very top layer, and it's not very deep. Under the continents, it stretches between 40 and 70 kilometers, and it's mostly composed of lighter rocks like granite. Now, under Earth's oceans, that crust is only about 5 kilometers thick, but it's denser basalt rock. Now, choosing the right place to drill would be the first and most important step in your digging journey. If you started drilling your hole anywhere near the equator, well, you couldn't fall through it. That's because Earth's rotation would become a problem. Yeah, this is what scientists call the Coriolis effect. Even though Earth makes one full rotation every 24 hours, not everyone on the planet is moving at the same speed. It all depends on how far you are from the poles. At the equator, the surface and you are rotating eastward at about 1,600 kilometers per hour. It's 1,000 miles per hour. You could drill a straight hole at the equator, but you couldn't fall through it. Because of the Coriolis effect, you'd be slammed into the eastern wall of the tunnel almost immediately. Now, to save yourself from slamming into a wall, the tunnel would need to be a complex, mathematically precise curve. That's too much math for me. Now, at the poles, which are Earth's axes, there's barely any sideways rotation. Here, you could drill straight down. But which pole would you choose? The South Pole is on the continent of Antarctica, and the crust here is extremely thick, between 30 and 40 kilometers deep. The North Pole is right in the middle of the Arctic Ocean, and it sits directly over the Gackel Ridge. This oceanic crust is much denser than the continental crust, but it's thin. Here, tectonic plates are pulling apart so slowly that Earth's crust is less than 4 kilometers thick in some spots. So, by starting in the Arctic Ocean, you'd hit the Earth's mantle almost immediately. But you'd have to drill underwater, and that would make things difficult for you. This ambitious drilling project would take a long time. I mean, the Kola Super Borehole at 12 kilometers deep took scientists 24 years to drill. So, on average, they drilled about half a kilometer per year. Now, if you found a solution to the melting equipment problem and kept drilling to the core at the same pace, it would take you 24,984 years to get to the center. If you wanted to have this hole all done today, you'd have to have started this project during the last ice age, when mammoths were walking around. And you'd have to approach every one of Earth's layers in a different way. For starters, the crust. Columbia's mid-Cauca belt sits on a crust that's about 45 kilometers deep, so you'd have a lot of work to do. Now, for the first few kilometers, you'd use conventional rotary drilling with diamond bits. Yeah, I mentioned this was going to be costly. That's exactly why you'd be going through the gold-rich rock first. But as you went deeper, the rock would get so hot, it would be like drilling into hot, squishy plastic. German scientists once drilled a hole 9.1 kilometers deep, and they clocked the temperature 265 degrees Celsius. That's over 500 degrees Fahrenheit. Drilling in Colombia would get even hotter, and at the very bottom, the crust could be as hot as 1,000 degrees Celsius. Yeah, any mechanical drill would become useless. You'd have to switch to millimeter wave directed energy drilling. This is a kind of super-powered heat laser. A surface machine called a gyrotron would send waves down a metal tube through the crust. There, it would heat up the rock so much, it would practically vaporize. If you blasted this laser into the crust 24/7, well, it would take you 1 year to get to the bottom. The next stop is the mantle, specifically the upper mantle. The upper mantle stretches from 45 kilometers to 670 kilometers deep. It's mostly made up of rock called peridotite, but it's very, very hot, around 1,500 degrees Celsius. You'd need an extreme heat-resistant suit to go down there. And of course, you'd keep using your laser to cut through this rock. But here's the problem. This intense temperature down here turns rock into thick peanut butter. You ever try poking a hole in peanut butter? It doesn't stay as a hole, does it? It closes. So your hole to the center of Earth would keep closing as you were beaming it. The only way around that would be to somehow crystallize the walls of your tunnel to the planet's center as you drilled. It would be a long and difficult process, and we don't even have the technology to do this right now. But if you somehow kept drilling at the same pace you drilled through the crust, it would take you 14 years and 4 months to get all the way down to the lower mantle. Yeah, you worked so hard and so long, and you still didn't even drill through the whole mantle. Now, the lower mantle is unimaginably extreme. At this point, you'd be drilling through deep earth, fighting through crushing pressure over 1.3 million times stronger than on Earth's surface, and soaring temperatures of 3,700 degrees. That's 6,600 degrees Fahrenheit. The heat radiating from the walls would be enough to incinerate any material. If you were planning to get this deep into Earth, you'd need advanced active cooling. And you guessed it, we don't have that kind of tech right now. The lower mantle is very thick. It stretches from 670 kilometers to 2,890 kilometers deep. If you could even keep up with the speed you've been drilling earlier, well, it would take you more than 50 years to get through this incredibly hot and thick layer. Finally, after 66 years of non-stop drilling into the planet, you'd get to the outer core. You're not at the core yet, but you'd be close. Here, everything would change. You'd no longer be in solid rock. The outer core is an unimaginably vast, turbulent ocean of soupy liquid iron and nickel. The temperatures here are so extreme, they're in the same range as the surface of the sun. Yeah, if you thought the mantle was hot, well, the outer core is between 4,500 and 6,000 degrees Celsius. I have no idea how you could survive here. This kind of temperature and all that pressure would incinerate and crush you within milliseconds. And if you did survive, well, drilling here would be impossible. You just can't drill through a liquid. You'd have to sink a physical, indestructible pipe through the molten metal to keep your tunnel open. And you'd be sinking 2,260 kilometers of piping into a swirling liquid iron ocean. But here's the good news. Instead of mechanically pushing it down, you could just let gravity do the work. If your pipe was made of an ultra-dense material that's heavier than the surrounding liquid iron, well, it would sink under its own weight. And it would sink fast. That's because the liquid iron in the outer core has a consistency similar to water, even though it's over 10 times denser. So it wouldn't create much resistance for the pipe. It would take you a little over 5 days to push the pipe down. Now, the outer core is what generates Earth's magnetic field. Yeah, all that molten iron moves around because of extreme heat and the planet's rotation. Because this liquid metal conducts electricity, all that swirling creates a geodynamo effect. It's like a massive natural generator. It generates the electric currents that power our magnetic field. And because of all that, the magnetic forces here would be 50 times stronger than you experience at the surface. Your navigation equipment and electronics would be useless at this point. You'd be drilling blinded by Earth's magnetism. But like I said, it would take you a few days to sink through the entire outer core. And finally, you'd reach your destination. Well, almost. Earth's inner core stretches from 5,150 kilometers to 6,370 kilometers. You wouldn't be at the center of Earth yet, but you'd be close. The pressure here would be 3.6 million times higher than the pressure at sea level. And the temperatures would be hotter than the surface of the sun, up to 6,000 degrees Celsius. That's over 10,000 degrees Fahrenheit. Now, you'd think it would be another layer of metallic soup, but no. The core is dense, all because the incredible pressure is keeping it solid. Now, you'd re-engage your laser beam. Hopefully you took that thing with you through the outer core. Now, there would only be about 1,220 kilometers between you and the center of the planet. With your laser drill, it would take you just under 28 years to get there. But finally, you'd be standing at the very source of the force that keeps your feet on the ground, right at the center of the planet. But you'd feel absolutely nothing. Now, we think of gravity as a downward force, but down just means toward the center of mass. As you drill toward the core, more and more of Earth's mass would actually be above you. Once you were in the center of Earth, inside a solid sphere, the mass of the planet above your head would cancel itself out. The gravity from the bits of Earth to your left would be canceled out by the bits of Earth to your right, and stuff above you would pull you up just enough to negate some of the pull from the core below. By the time you reach the exact center, you'd be in the middle of a global tug-of-war where every side is perfectly matched. You would just drift in the middle of it, just like an astronaut on the International Space Station. Every atom of the Earth would be pulling on you, but because they'd be pulling in every possible direction at once, the net force would be zero. Now, to get to the other side, you'd have to repeat the entire process in reverse. From the center, you'd have to drill through another 1,220 kilometers of solid inner core. Now, since you'd be working against gravity, even though it's weak at first, it would feel like a constant uphill climb. Then you'd blast through the 2,840 kilometers of mantle and the final thin layer of crust. Now, if you kept your laser drill running at the same record-breaking speed, well, The entire return trip from center to the surface would take another 90 to 100 years. Okay, so your megatunnel is finally finished. It goes from Columbia straight through the core all the way to the other side of the planet. And now is the time to send you through it. You put on a heavily shielded spacesuit, pump all the air out of the shaft so that the air resistance doesn't burn you up, and then you jump. At first, it would feel like regular skydiving, only you'd keep accelerating because there would be no air to slow you down. Your speed would keep climbing. By the time you hit the mantle, you'd be moving at insane speeds. Exactly 21 minutes after the jump, you'd blow past the center of the Earth at 8 kilometers per second. That's about as fast as the International Space Station zips around Earth. You'd blast through the zero-gravity core at maximum speed, and now you're heading up the other side of the planet. Gravity would be pulling against you now, and it would slow you down. But your massive momentum would carry you all the way out through the outer core, the mantle, and the crust to the opposite side. Exactly 42 minutes after you jumped, you'd pop out the other end of the hole. Your speed would hit zero for a split second at the surface. You'd be right in the middle of the Indian Ocean, near Indonesia. Now, if you didn't grab onto the ledge at the exact second you reached the surface, gravity would pull you right back down. You'd fall back toward the core. You'd be falling back and forth inside of Earth forever. Yeah, you probably shouldn't have jumped here, but it's too late. You're stuck. The moon's surface is made up of long-dead volcanoes and impact craters from asteroids. But have you ever wondered what might be inside it? We could find out one day by digging a tunnel through the moon. How long would this take? What mysteries would we find inside? And how would gravity affect our dig? This is What If, and here's what would happen if we dug a tunnel through the moon. Unlike the Earth's layers, we don't know much about what's inside our moon. But we do know to get through it, you'd need to dig over 3,000 kilometers. And with today's technology, doing something like this would take about 1,300 years. But what if we managed to fast forward this with more advanced technology? What would happen then? To start our journey through the moon, we'd first want to choose an area that would give us a head start. The best choice here would be the South Pole Aitken Basin. This is a massive basin that's 8 kilometers deep. For comparison, the deepest hole on Earth is 12.2 kilometers, so this would save us a lot of time. Now it's time to start digging. The first layer you'd need to worry about would be the moon's regolith, also known as the moon's outer crust. It may not seem like it at first, but this layer is surprisingly dangerous. Regolith is billions of years of crushed asteroids and moon dust. It's razor sharp and very fine, and can easily get into your suit and your drill, which will wear them down over time. And make sure you don't accidentally inhale any of this stuff, as it can cause lung cancer. You'll be digging through the regolith layer for up to 15 meters until you reach the lunar crust. This layer is made up of bedrock, and it's where you might make some money, since rocks in the crust contain lots of titanium and aluminum. You'll also be able to find iron, calcium, and magnesium. We could either bring these back to Earth or use them to help us colonize the moon. This layer is about 100 kilometers deep. Once you're through it, you'll then have to deal with the lithosphere. This layer used to be magma that would supply the moon's volcanoes, but thankfully it's cooled and is now solid. What we'd be less thankful for is that this layer is nearly 1,000 kilometers deep, so you'd keep drilling and drilling and drilling and drilling until you've finally reached the asthenosphere. What's different here is that this layer is made up of molten lava. At this point, your journey would definitely be over, as you'll be facing temperatures of up to 1500 degrees. But we'll give you a special suit to help you survive this. Oh, and a special drill, too. Now, you wouldn't be drilling at this point. Instead, you'd be trying to swim your way through this magma. And as you get past this, you'll be met with another liquid. But this time, it will be liquid iron, which is the outer layer of the moon's core. Its radius is roughly 330 kilometers, so let's hope your suit can still withstand the immense heat. And as you drill your way through these thousands of kilometers, you'll notice that the gravity has been changing. As you reach the center of the moon, the gravity will reach zero and you'll be completely weightless, floating in the moon's inner core made of solid iron. So, now that you've reached the center, it's time to make your way back out. Through the outer core, out through the asthenosphere, then the lithosphere, inner crust, and finally the regolith layer. And drilling through wouldn't take as long as it did the first time. That's because the inner crust is about 40 kilometers thinner on this side of the moon, which is the side that faces the Earth. Digging through the moon has some benefits, but overall it wouldn't be worth it. After all, this project would take 1,300 years, and who wants to wait that long? If you were to drill straight down into Mars, what would you find? Would the red planet reveal its true colors? Would you finally discover life on Mars? And how would drilling through Mars compare to drilling on Earth? This is What If, and here's what would happen if we drilled through Mars. This is the Jezero crater on Mars, and 3.5 billion years ago, it looked very different. It used to be an ancient river delta that carried clay minerals into the crater lake. It might have even hosted Martian life. Fast forward to now, and the Jezero crater has become a perfect landing site for NASA's shiny new rover. Meet Perseverance. If I were to search for past life forms on Mars, this is the place I'd start looking too. Only instead of collecting rock samples, I'd send a rover to drill through the surface. What's the worst that could happen? Did you know that Mars has Marsquakes? They're like earthquakes, but on Mars. NASA's Martian lander called InSight detected 480 of these Marsquakes in 2020 alone. Luckily, there isn't much out there to damage. For us, these Marsquakes are a good thing. They create seismic waves that our scientists can study, and based on these studies, they can theorize about the Martian interior. But you and I would be doing this the hard way. We would drill through Mars to see what secrets it holds inside. If you started drilling through the reddish iron oxide abundant surface layer of Mars, the first thing you'd discover is that the interior is not so red. But don't be surprised. In 2012, NASA sent the Curiosity rover to Mars. It landed about 3,700 kilometers from the Jezero crater. Curiosity discovered that the layer beneath the surface of Mars is slate blue? Yeah, that's because it contains high levels of silicon. Huh. And as you drill, you should continue to expect the unexpected. The next discovery you'd make is that the crust layer on Mars is thinner than the one on Earth. Remember InSight? This little lander indicated that the Martian crust is only around 20 or 37 kilometers thick. Compare that to the Earth's crust, which is approximately 40 to 50 kilometers thick under the continents. If water still exists in liquid form on Mars, it could be several kilometers inside this crust. And there are radioactive elements in the liquid mantle below the crust. These elements release geothermal heat through their decay, and it should be enough heat to melt thick sheets of subsurface ice. This geothermal heat could be why there was liquid water on Mars 4 billion years ago, even though the surface temperatures were below freezing. But enough theory, let's keep drilling. Boring through Mars would be even harder than drilling through Earth. The deepest we've ever drilled on Earth was 12.2 kilometers into its crust, and that came with high budget costs, technical difficulties, and plenty of bad luck. But on Mars, this would be an unimaginably tricky endeavor. The InSight lander tried drilling, but it encountered unexpected soil properties. The drill probe was trying to go 5 meters deep, but could only go a fraction of the distance before popping out. Then there was Curiosity. It experienced a mechanical error. The drill feed mechanism that was supposed to move the drill bit forward wasn't moving when commanded. Luckily, scientists designed a new, more human form of Martian drilling. Now, the rover uses the force of its robotic arm to push the drill bit into the surface as it spins. But don't get your hopes high about reaching the mantle of Mars too soon. It took Curiosity the entire day to drill a mere 5-centimeter hole. Based on that, going 5 kilometers down would take up to 300 years. And you'd need a bigger drill. There's still so much we have to learn about Mars, but maybe drilling isn't the most effective way to do it. Especially since we haven't gotten very far into the crust of our own planet. Imagine what it would be like if you could wake up in your New York City apartment at 7 a.m. and make it to your job in London, England by 9:30 in the morning. That would be a possibility if we dug tunnels between the two continents. Just try not to get sick. Believe it or not, something like this is possible. But how would we make a tunnel like this? And how much would it cost? This is What If, and here's what would happen if we dug tunnels between continents. That's right, a tunnel like this is possible. I mean, a tunnel that's similar to this already exists. It's called the Channel Tunnel, or Chunnel. And in just about 35 minutes, you can drive from England to France. Without it, you'd have to take either a ferry or a plane. Compared to what we'd be building, the Chunnel is tiny at just over 50 kilometers. Our tunnel would be over 5,500 kilometers if we wanted to go from New York to London. So, how would we make our tunnel? Let's use the Channel Tunnel as an example of what our tube might look like to give us some context. The Channel Tunnel took 6 years to build, and it also took decades of planning before that. As for the price, if we were to build another tunnel today, it would cost a whopping $13 billion. Okay, now multiply these numbers by 100, as that's how much bigger our tunnel would be, and you get the idea. This thing would take an incredibly long time and would cost a ridiculous amount of money. But let's assume we've got all this covered, and we have unlimited time and money. Just because we have enough resources doesn't mean we should be stupid in how we use them. If we tried to avoid all the water and went underneath the seafloor, we'd have to bore through the ground from England all the way to America. This would take an incredibly long time. And there's always the possibility that the tunnel we built more than 5,000 meters underwater would cave in from the ocean's pressure. Instead, the best way to make the tunnel might be like this. You would make one massively long 5,500 kilometer tube and put it over the ocean. Then, using anchors, you would drag the tube down about 45 meters. You would then secure the tube using wires tied to the ocean's floor. Okay, now that we have our tunnel, what do we fill it with? Will we drive through it? Pfft, that's so 21st century. Instead, we'll be taking a train. I know, that might sound even more old school than using a car, but this won't be just a regular train. To travel through our tube so quickly, we'd need to use vac trains. This system would essentially act as a vacuum that would take all the air out of the tube. This would allow the train to travel at incredibly high speeds due to there being little or no air resistance. Not only that, but our train would also be levitating, using high-powered magnets or with air, kind of like an air hockey table. Where are my Canadians at? After propelling the train forward with a high-powered engine, it could cruise for hundreds, if not thousands of kilometers since there's no friction to stop it. With this little resistance, the vac train can go up to 8,000 kilometers per hour. But we won't be going that fast, as that could be incredibly dangerous. Not just for the train, but for your physical well-being. Instead, you'd be going about 2,000 kilometers, which is almost double the speed of sound. But don't be too alarmed by this. Your body should be able to handle it just fine. After all, the Concorde passenger jet flew this fast for years before it was decommissioned. So, it is possible that we'll see a pipe that connects across the Atlantic Ocean one day. As long as we have enough money, time, and resources. Now, imagine that the supersonic train actually exists, and we could casually travel from Europe to America in just under an hour. This is the longest underwater pipe on Earth. It stretches to the bottom of the deepest place on the planet, where only a few people have ever visited. And we're about to take you on an epic journey to construct it. What materials would be suitable for the task? What creatures would lurk around you? And at what point would constructing the pipe become unbearable? This is What If, and here's what would happen if you built a pipe to the bottom of the Mariana Trench. There's a reason why only a few people have ever made it to the bottom of the Mariana Trench. Let me tell you, it's not the most pleasant of trips. The deepest part of the trench, called the Challenger Deep, hits the mark at 11 kilometers. No light makes it that deep, and the temperature is just a few degrees above freezing. If you were to dive down this deep, with or without a protective suit, the pressure would crush you. It would feel as if you had 100 elephants standing on your head, or as if you piled 5 blue whales on your shoulders. That's what I call being under pressure. So, how would we go about constructing a pipe in an environment where no human can survive? Let's start from the beginning. Building a pipe like this would require a lot of planning, preparation, and millions of dollars. You'd be aiming for a pipe that could withstand pressure 1,000 times greater than our normal atmospheric pressure. What materials would even stand a chance? I could suggest steel, since that's what most water pipes are made of. It's durable and cost-effective, but transporting 11 kilometers of pipe into the ocean as one piece would be next to impossible. You might be better off with polyester or vinyl resin pipe. You could reinforce it with fiberglass and assemble it underwater. When you get to a depth that would crush the fiberglass, you could add some steel. Well, that's the plan. Now, let's see how it would play out. As you descended 200 meters underwater, you'd leave the epipelagic zone and find yourself in the mesopelagic zone. Those are the top 2 of 5 oceanic layers. Your lungs would be getting compressed as you descended deeper and deeper. But it would still be doable at this point, as long as you were wearing a pressure suit. It would be dark, but you'd see twinkling lights once your eyes adjusted to the darkness. Those would be the bioluminescent animals that call the mesopelagic zone their home. At 1,000 meters, you'd enter the bathypelagic zone of the ocean. And you'd better get into a submarine because no pressure suit would be able to keep you from getting crushed now. From this point on, underwater robots would take over the construction and maintenance. The pipe itself would need to be getting thicker so that it could bear the increasing water pressure. And you'd need a powerful flashlight because the only visible light down there is produced by creatures themselves. You'd descend deeper and hit the 4,000 meter mark. At this point, you'd enter the abyssopelagic zone. Now, you'd truly see what dark looks like. No light at all can make it down to the abyssopelagic territory, and the water temperature is near freezing, so very few animals live here. You'd be lucky to see a few tiny squid. Okay, you're in the home stretch now, in the waters of the hadal-pelagic zone. In the deepest, the darkest, the most unexplored place on Earth. I wouldn't recommend you descend all the way down. At the bottom of the Mariana Trench, the pressure is about 1,100 ATM. That's the feeling of 100 elephants standing on your head. Building a pipe here would be challenging. You'd need to send some very durable robots to the bottom of the trench because these depths can implode even the toughest of them. On top of enduring extremely high pressure, they'd have to be able to withstand the temperatures of just above freezing. Nothing larger than 3 centimeters can live in this dark, cold, and absolutely hostile environment. So get cozy and let the robots finish the pipe. You know what might be the best way to travel to the other side of the world? By drilling your way right through the planet. This would be the journey of a lifetime, if you don't mind riding through molten rock and crushing pressure. What would you see along the way? How long would this journey through Earth take? And how would a gravity train keep you alive? The heat is on and you're under all sorts of pressure. This is What If? And here's what would happen if you drilled a hole through Earth. Imagine going from Argentina to China in less than an hour. All you need is a hole straight through the Earth. But drilling this hole would be the hardest part of the endeavor. You could just handle it supervillain style and fire a laser at Earth. But today, we'll be taking a trip through the biggest hole we've drilled in the history of our planet. Sit tight because this is gonna be one heck of a ride. The first thing you'd need to do would be to drill the deepest hole humanity has ever imagined. We've already drilled holes through the Earth on What If, so you know what to do. First, you'd need a really big drill, and it would take a few years to complete this project. You'd be working in enormous heat and pressure, and it would increase the closer you get to Earth's center. But when the hole is finished, you'd have your very own gravity tunnel, a gateway between one side of the Earth and the other. I'll explain how it would work in a moment. Next, you'd need to find yourself a comfy vehicle to get you through the Earth. If you just jumped into the depths of the Earth, you'd burn to a crisp and crushed into a pancake. So, hop on the gravity train. This train would accelerate using only the force of gravity, and it would protect you from the searing heat and extreme pressure. The first leg of the journey would take you through Earth's crust. Depending on where you begin your trip, the crust can be 5 to 70 kilometers thick. And amazingly, it only makes up 1% of the entire Earth. You'd start your journey feeling pretty carefree, and at 20 meters below the surface, you'd be at the same level as subways or the Paris catacombs. But let's go a little further down. At 2.5 kilometers, you'd be at the same depth as the deepest fossil ever discovered. And once you get to 3.6 kilometers, you'd be able to see the devil worm. It's the deepest living animal ever found. Is it just me, or is it getting hot? Believe it or not, some people are working at this depth. The Mponeng gold mine in South Africa is so far down that the heat is an issue. And believe me, you wouldn't enjoy the 60 degrees Celsius temperature down here. Then, gravity would take you further down. At 8.8 kilometers below the Earth's surface, you'd have traveled further than the height of Mount Everest. And at 11 kilometers underground, you'd be deeper than the Mariana Trench. At 12.26 kilometers, you would reach the same depth as the Kola Super Deep Borehole. It's the deepest hole we've ever dug. And now, you'd really feel the intense pressure on your body. At this depth, air pressure is 4,000 times the pressure at sea level. As you approach the end of the first part of this epic journey, you might get to see a plethora of gems. I'm talking about rubies, sapphires, and emeralds. They could be valuable souvenirs if you make it through to the other side of the Earth. And at 40 kilometers down, part 1 of your voyage would be behind you. Or above you, depending on how you see it. Let's go onward to the second layer of Earth, the mantle. Most people think it has a lava-like texture, but at this shallow depth, relatively speaking, it's rock solid. Only when you're deeper will it start becoming molten. This would be the longest part of your journey. That's because the mantle makes up an impressive 84% of Earth's volume. The mantle is about 2,900 kilometers thick. You wouldn't see much inside it, except for one dazzling exception. At this depth, the enormous pressure and heat forms diamonds. They make their way to the Earth's surface through volcanic activity, and that's where we humans find them. But you are lucky and find them at their birthplace. Don't be shy, grab a few. As you arrive about 410 kilometers below the surface, things would start to get weird. The mantle's rock would be molten hot, but instead of it staying in its melted state, the mantle would turn hard. That's because of the extreme pressure. Moving on to the bottom of the mantle, a mere 1,000 kilometers down, you would experience the force of mantle blobs. These are supercharged plumes of hot rock, and if they surfaced, they would become devastating supervolcanoes. No need to say, you'd feel extremely hot. You'd be almost halfway through the Earth, and that must mean you're approaching the outer core. At depths of 3,000 kilometers, the outer core is made of iron and nickel. And boy, would it be hot! The temperatures around you would range from 4,500 to 5,500 degrees Celsius. At 5,000 kilometers below the surface, you'd reach the Earth's inner core. This giant solid iron sphere has a mind-boggling temperature of 5,200 degrees Celsius. And the pressure is a crushing 3.6 million times more than at sea level. Let's hope your gravity train would be up to the challenge at these extreme temperatures and pressures. I didn't read the manual, but I'm sure you'll be just fine. Finally, you would make it to the halfway point of your subterranean voyage. Right at the center of Earth, the mass would be equal in all directions, and you'd get to experience zero gravity. But remember, that was just half the journey. you'll have to do that all over again, but in reverse to finish your trip. This journey would put you under a lot of pressure. It would make you hot, most likely uncomfortable, and rich. You did collect the diamonds, didn't you? Now, how long do you think it would take to get from one side of the Earth to the other? Okay, it's time I told you more about the gravity tunnel. This is a theoretical passageway through the Earth, or simply a hole through the Earth, as I like to call it. If it's created correctly, you could get from one side of the Earth to the other in about 42 minutes using a gravity train. But as I mentioned before, traveling through the Earth would be the easy part. It's the drilling that would be hard. If we could engineer such a feat, it would revolutionize travel. And you'd have one short but epic journey. This is the Mariana Trench, the deepest place on Earth. It stretches 11 kilometers down below sea level, but what if we made it even deeper? Well, get a giant drill because we're about to dig a hole in one of the most hostile environments on the planet. Has anyone attempted to do this before? What kind of nasty conditions would you be stepping into? And could you drill all the way to the Earth's core? This is What If, and here's what would happen if you drilled a hole at the bottom of the Mariana Trench. Here in the Western Pacific, the Mariana Trench isn't the most popular travel spot. It's frigid and bone-crushingly deep, not something you'd pick for your vacation. So it's not surprising that only a handful of people have ever visited it. It's a long way to the Challenger Deep, the deepest part of the Mariana Trench. Drilling through it would be both expensive and dangerous. You'd need to troubleshoot on the spot, work in complete darkness, and survive cold temperatures. You might not come back safe and sound. Okay, now that we've sparked your interest, it's time to buckle down and get to work. It would be costly to get to the bottom, but it would be even more expensive to start drilling through it. You'd need very specialized equipment. While the water temperature around you would be just above freezing, you'd need to worry more about the crushing pressure. At the bottom of the Mariana Trench, it would be 1,100 times the atmospheric pressure at sea level. You wouldn't be able to survive in just a diving suit. You'd need to jump into a submarine designed to withstand such high pressure. And all the drilling equipment would need to be specifically designed for the depth. Before you could start drilling, you'd have another issue. There would be no way to anchor your expensive drilling equipment at the bottom of the Mariana Trench. You'd need to find a way to stabilize your rig. And if that's not bad enough, you'd need to assemble everything on site. Yeah, you'd be moving heavy pipes and drills around, and you'd need to bring some powerful lights because it would be dark. The Mariana Trench is just too deep for sunlight to reach. Okay, once you dealt with all that, you could start drilling. And that endeavor would bring even more surprises. We know more about the surface of the moon than we know about Earth's ocean floor. But one thing we do know is that it can get hot. In 2011, researchers drilled the Japan Trench, just outside of Japan. They went down 6.9 kilometers and found that the temperature below the sea floor was scorching. At just 1 kilometer down, the temperature reached 120 degrees Celsius. Another challenge you'd face would be the ocean crust itself. It's composed of igneous rock or hardened magma. This would wear down your drill pretty quickly. You'd need to keep replacing your drill bit. And you better mark the hole with a re-entry cone. At the bottom of the ocean, it would be tough to find the spot you'd already been drilling. It would be like lowering a long strand of spaghetti into a 0.6 centimeter funnel at the deep end of an Olympic swimming pool. Yeah, that's hard. So, just how deep into the Earth's crust would you be able to drill? Well, that depends. How patient are you? And how much money do you have to spend on all that drilling equipment? If you're thinking about drilling all the way to the Earth's core, forget it. Oddly enough, drilling through the crust from the deepest place on Earth wouldn't help you get to the core faster. No, that's because Earth isn't perfectly spherical. Yeah, it bulges at the equator, making the drilling distance to the center of the Earth from the Mariana Trench longer. If you wanted to drill all the way through the Earth, you'd be better off starting your project near the poles, as they are closer to the Earth's core. This is the deepest hole mankind has ever dug. It's a straight drop into the bowels of the Earth. For 20 years, Russian scientists and engineers drilled deeper and deeper, hoping to uncover whatever mysteries the hole may hold, earning it the ominous nickname of the Well to Hell. What would happen if, for whatever reason, you fell into this hole? What would happen to your body? How deep would you fall? And what would you find at the bottom? This is What If, and here's what would happen if you fell into the deepest hole on Earth. So, you managed to take the plunge. You'll start plummeting at about 10 meters per second, and every second after that, it gets faster. If we take terminal velocity out of the mix and assume you weigh 80 kilograms, you'd eventually reach a speed of 490 meters per second. So, as you fall deeper and deeper, what would happen to your body? Falling at such high speed, you'll start to notice things getting a little toasty as your heart rate starts to elevate and panic sets in. You might find it getting a little harder to breathe. Why? Well, at 150 meters down, your poor lungs would be getting crushed by the constantly increasing air pressure. You might also encounter what cave explorers like to call foul air, deadly underground pockets of carbon dioxide. Great. Things can't get much worse, can they? Yeah, they can. Less than 3 kilometers into the trip, you're going to see your skin start to burn up. Literally. And as you continue to fall, it only gets hotter and hotter. This is because you're being pulled closer to the gravitational center of Earth and its molten core, which is baking the planet from the inside out. A temperature of 80 degrees can severely burn a person's skin in less than a second. At this point in the hole, you're feeling heat of over 180 degrees. On the bright side, you've probably already passed out. When you fall out of a plane, you can pass out from lack of air, but wake up as oxygen becomes more available and catch a glimpse of the ground as you smack into it. Down here, you're not waking up. Okay, so things don't look good. But let's say you came prepared and wore an atmospheric diving suit to help with the increasing pressure as you fell. It's heavy, but it will help with that breathing problem. In 2016, Luke Akins jumped from over 7,600 meters without a parachute and survived without a scratch. Granted, he'd landed in a net, so if he's allowed to have one, you can too. Okay, so you land in the net. Great. Including your terminal velocity, you have successfully managed to free fall 12 kilometers straight down at a speed of 200 kilometers per hour. How long were you falling? Well, factoring in air resistance and terminal velocity, the whole trip took just over 3 minutes. And now, you've got to get back out. This is not going to be easy, but it may not be impossible. In 2018, Alex Honnold managed to scale Yosemite National Park's 914-meter tall El Capitan granite wall without ropes in just 4 hours. Granted, he wasn't wearing a huge suit like you are. This big outfit wouldn't help you climb, and you would need some climbing equipment to help you get a better grip on the walls of the hole. But what's it like down there? To answer that, let's flash back to 1971 in the Kola Peninsula of northwest Russia, to be exact, when Russia began work on the Kola Super Deep Borehole. Measuring in at just over 12 kilometers deep, the Kola Super Deep Borehole is the deepest hole humankind has managed to dig on Earth. Team Kola had managed to break the world record for drilling depth, trying to get a leg up on the US during the Cold War. Eventually, though, they encountered temperatures of 180 degrees, which melted their equipment, so the hole was capped in 1992. When you're at the bottom, you'd find things are warm, to say the least. Not to mention, your body would be dealing with air pressure equal to 54 elephants perched on top of your head, weighing in at a whopping 378 tons. Talk about a headache. At least you could admire some of the 2.7 billion-year-old rocks down there. But really, could something like this, falling down this hole, ever happen? Who knows? To be honest, we're still trying to figure out the equipment requirements for digging this deep, let alone finding someone crazy enough to take the plunge. Luckily, the Kola Super Deep Borehole only has a diameter of 23 centimeters, so it's too narrow for you to trip into. And even with its record-breaking depth, the Kola Super Deep Borehole is only a fraction of the thickness of the Earth's crust. Hundreds of meters underground. Large enough to house tens to hundreds of thousands of people. And walls strong enough to withstand the force of a nuclear blast. These are some of the world's deepest and largest bunkers. But even in an apocalypse, you wouldn't be completely safe in one of these. Earth-penetrating weapons, like the 1.2 megaton B-83 warhead, can demolish bunkers 300 meters deep. What would it take to build a deeper bunker? What would life be like inside it? And why can living underground be dangerous? This is What If, and here's what would happen if we built the world's deepest bunker. The deepest hole in the world, the Kola Super Deep Borehole, penetrates about 12 kilometers deep into the Earth's surface. In comparison, underground bunkers are usually built at much shallower depths. One of the deepest bunkers in the world, the Cheyenne Mountain Complex, is only about 610 meters deep. So what's the problem? If we can dig thousands of meters into the Earth, what's stopping us from making a bunker just as deep? The truth is, we do have the tools and technology to build the world's deepest bunker. The only other things we'd need are lots of time and money. Lots and lots of money. As we dig deeper and deeper, the soil pressure will continue to increase. It'll become expensive and difficult to keep the hole from collapsing in on itself. We could use sheet pile walls to support the soil pressure. They're commonly used in construction and excavation, but the deeper we dig, the harder it is to construct the walls. Another way we could work around this is to dig narrower and narrower as we reach the bottom of the hole. It would look similar to an open pit mine. The soil would be stable without the need of any support. Then, all that's left is to build the bunker right in the middle of the hole and fill it back up afterwards. Sure, it'll be safer, but ridiculously pricey and time-consuming. Some of the most expensive bunkers cost millions of dollars to build, so it's safe to say that building the deepest bunker could easily cost a fortune. But what if we had the money and resources to build the bunker? What would life be like if we had to stay down here? Now, don't be expecting a 5-star bed and breakfast. You'll be surrounded by thick, tightly sealed concrete walls, so no gas, water, or radiation can get through. And before you get settled in, You'll need to make sure that the bunker has a reliable power source underground, a good filtration system, and an ample supply of food and water. The food down below in the bunker wouldn't be much different than what astronauts eat up above. Your diet would consist of dehydrated or freeze-dried foods to prevent spoilage and to save space. That is, until hydroponic farms can be built. This is what farming could look like in an underground bunker. Instead of soil and sunlight, some hydroponic farms use nutrient-rich water and artificial light to grow plants. Not only that, but by using aquaponics, fish and plants can be farmed together, even indoors. Eating fish can help provide us with an essential nutrient that we'll definitely be lacking underground: vitamin D. Sadly, if you're living underground, you won't be able to get under the sun and work on your tan, but there are much bigger problems you're going to have to worry about. Most of the vitamin D we get is from the sun. We need this vitamin to keep our bones strong and healthy. Ultraviolet A and ultraviolet B rays from the sun are also essential so that we can make vitamin B in our bodies. It helps boost our immune system, and it keeps us happy and energized. Woohoo! A lack of sunlight can cause other health problems too. It can cause seasonal affective disorder, a type of depression that occurs in fall and winter when there's less light. The sun also helps to keep our circadian rhythm in check. It's the body's internal clock and helps to regulate our sleep patterns. Without the sun, people in isolation have slept as much as 48 hours at a time. Maybe we could use LED lamps to provide artificial sunlight and a diet with a lot of vitamin D-rich foods. Okay, now that everyone has enough food and light, there's one more important thing that we'll need to take care of: the community. With everyone's lives confined to the bunker, staying connected will be ever so important. You'll need to rely on other people as you adapt to this new lifestyle. Creating a normal life in the bunker where kids go to school, adults go to work, and each person has their own room can help everyone adjust. Building the world's deepest bunker might keep you safe from what's happening on the surface, but making sure everyone is healthy underground is just as important. Alright, now that you know what it would be like in the world's deepest bunker, what if we built the world's tallest tower? One that reached outer space? Well, that's a story for another What If. There's a problem with Earth's core. It's right here under our feet, but we've never actually seen it. Today, we're going to fix that. We're going to find a solution to drill all the way to the center of Earth. And then we'll see you fall